Hello everyone, and in this video I want to show how to create a linear gradient, but I want to show multiple ways because I don't just want to use the linear gradient node and then show that we can make a gradient. I just want to show multiple methods because some methods are much more better than just using this linear gradient node, and it just comes down to what you're trying to do. So obviously the first of all is going to be linear gradient node. What I've simply done is I've created a material which is empty, nothing crazy, and this is like an instance that I created by doing create material instance and then simply just dragged it on three of this stuff. I'm in global right now, so just to show you guys, okay, this is just, if I click here, you could see like local and global, because in global every axis would be in same direction, and in local it would be like based on which way it is facing. So just to tell you guys that I am currently in global, and you will understand why later. These are four models that I have: a sphere, a plane, a cube, and one stylus cliff that I'm practicing because I'm trying to make some stylus cliff. Now this is the linear gradient node. If I press to U, if I use U gradient, if I click this, you could see it basically created a linear gradient from left to right. So if I'm also being in this plane area, okay, so in this plane, which is this one, we basically have we basically have UV of like 1, like something like this. This is a page that I'm working on. I will make this public when I've finished doing it, but basically I wanted to have a guide on this stuff on VFX and all, but this would come in handy for lots of different stuff too. But basically a UV coordinate is like this, right? So it is 0 0 because U is 0, V is 0. Here the point is 1 0, here the point is 0 1, and this is 1 1 around here. It is simply a graph for just showcasing this UV coordinates of these 4 points, and UV is nothing but XY coordinates, but to not confuse it with XYZ, because you know we have XYZ in transformation. It is usually called UV. So just to not get confused with XY coordinates, XYZ coordinates, but basically they are just XY coordinates. What this is basically doing is that it is using our UV channels and basically just showcasing the U channel like this, or basically creating a gradient on the U channel. You could see like this. So you could see that even though this is something like this where it is going left to right, you could see some of the areas are different because that's just how UV are made in whatever software it is made. These are just primitive stuff that I added. So if I add it from here, okay, but this is something that I made, and just based on how the UV coordinates are made, the linear gradient would also look different. You could see. And usually when you're working for VFX like sprites and all, then usually this is more than enough, where it just takes, you know, a UV coordinate and you just add some textures in here and all. But if you obviously connect it to V, it will go from top to bottom like this. If you do, let's say 1 minus, it will do opposite of what it is. So right now it is going top to bottom. It will go bottom to up like this. After this, if you, let's say, add a power node, let's promote this to a parameter. Let's apply. The default power should be 1. If I go to the parameters and if I increase this, you could see how this is actually increasing. But now what if I want to move it up and down, right? I want this UV to move up and down, which is why in the linear gradient we have UV channel. You could see it says UV V2. Basically it means that it's 2 vector or float 2. So if I just add a texture coordinate node, you could search for texture coordinate or press U and do left click. If I add this, nothing's going to happen because it is by default using this one. But if I decided to, let's say, add around here like this, and let's promote this to parameter. Let's go to this one, and this is called P, right? So if I move this, you could see I can now move it. So with this channel, I can reduce the effect, and with this channel, I can increase it. Oh, sorry, I can offset it. After this, if I, let's say, add a cheap node, a cheap contrast, I mean, like this, and promote this to a parameter. Let's apply. You could see I can make it be sharper like this, or I can reduce it. So if I make this something to be like 100, I can make it like fully sharp wherever it is like completely 0 and this is completely 1, because in alpha channels when we work with black and white textures, 0 is black and 1 is white. I don't know if I wrote something in here. Here you could see when a grayscale texture is there, black is 0, white is 1, and anything in between is like 0 0.1, 0.2, 0.5, 0.8 like this. And basically this can help you add like your specific values to this, this channels, where let's say I only want this to affect this one. So this is 1 and this is 0, right? So I can make something that only affects this much. Okay, I will explain other methods too, but let me explain this. So texture coordinate basically is our UV coordinate, right? So like this 0 0 1 0 0 1 1 1. When we add something, so let me see so this is how the textures usually go. So it keeps repeating like this. So you could see this is how the texture is 0 0 1 0 0 1 1 1. Let's say we added, let's say 2 in here, then what's happening is we are basically adding plus 2 around here. So it is turning to 2 2, this is turning to 3 2, this is turning to 3 3, and this is turning to 2 3 like this. So the texture is basically moving. All of this stuff is basically moving. So just remember that if you want to add something to your, or if you want to offset your texture, you can simply just add a node, because we are simply just moving left and right the UV coordinates. And obviously if you want to do, let's say only for X and Y, so rather than right now we are just moving it completely at one direction, right? So let me just remove the, where is it, contrast. Right now what we are doing is we are moving in both direction, both U and V. So if I just do, let's say break like this, it will give me, let's say break float 2, it will give me X coordinate differently and Y coordinate differently. In this case it does not make sense to like do like break it, simply because if you move this left and right, it's just going to look the same. Only thing would change would be like making it go up and down, right? Which is why doing a break doesn't make sense. But if you are having a different texture in here, which is not like consistent like this, where it does not go left to right like this, you could break it in 2 components like this, and then basically add like this to just move it in the X direction. And then you could basically add another node and then promote this to a variable, and this one would basically move it in Y coordinate like this. But again, this makes no sense, right? Because if I move it to X left and right, it's just going to look the same if you look like from here. Another thing, if you like break it, you also have to convert it back to a vector, because this one takes like 2 vectors, like U and V channel. It requires 2 float values. Right now I'm only giving it 1. So again, once you have broken it and then individually controlled one value, you could select make float 2, add this both like this, and then add it again to this one, because this takes 2 channels, right? And this way we are providing 2 different values like this. So for example, if you are using a texture in here like this, and let me just type, I don't know, I have a cloud texture. I can just select this into my UV and then just use the R channel, because this is a packed texture, it has multiple textures in it. You could see I've taken U, I've broken it into 2 components, I've added it separately, I've created a float and then created a texture sample, or created basically a texture, and then I'm saying that, hey, I want to offset this UV in this way for X and in this way in the Y. So if I go into this parameters, you would see I can move it left and right, and if I do this up and down, this is how it's going. But because we were using a texture which was like completely left to right same color, it didn't really matter to break it. But I just wanted to show you guys, okay, that this is possible. Another thing is using texture coordinate directly. So if I connect this texture coordinate to my base color, you can see that we basically see these colors. It is a representation of UV coordinates, which I already shown in here. If you are using Unity or another software, it will probably be flipped. So this one, it would be 0 0 in here, and this color would be on top, this color would be on top, but it's just same, everything is same. So this color would be on top, this one would be top, but the representation is like same. In Unreal, I don't know why it is shown in opposite way, But what I could say in here is that, hey, give me both of this component, because texture coordinate is just UV, right? So U and V tiling, you could see. Then I could, which is basically two float values. I could say, hey, give me the float values that you have separately and just give me the R value. And you get left to right, what you call a gradient. If I use G channel, I get G channel, which is top to bottom or up to down based on what you have done. And rest of it is similar. If you add a power node in here, it will basically make it be not banner. If you add, let's say, a power node, add this in here, add this in here, and let's say made this phi. You could see this is how it looks right now. So again, if you want to not use, let's say, linear gradient, you could use this one, and basically it will just show it based on your UV of how or where the V channel is right now. You could see this is showing V channel like this. This would be our X channel. Next method is VertexNormal world space. If I connect this to my base color, you could see the top one is showing blue because that is the color like blue, right? This, the left is showing red because that is the color red. Around here you could see red, and this is showing green color. Make sure you are in world space. So this is global, which is basically world space. If you go to local space, then you could see that if I move this is going to be my local space. This is going to be the red. But if I go to global, it will always be that one. Now the thing about world space, VertexNormal WS, is if I move this, you would see the red color always stays at the same direction because it is giving us in the world space. It's basically giving us like where the vertex normal is facing. If you guys don't know what vertex normal is, at every vertex, any 3D software creates a normal, which basically allows the 3D software to know how the lighting should work or which direction it is facing and all, like each surface. It basically allows to have like good lighting and all. So if I select this one, sphere, double click on the static mesh, go into show and click normal, you could see that these normals are facing outside of the face like this. If I select this one, go to cliff texture, show normal, you see it is facing each direction like this. This is something that you could change the direction of the vertex normal. It is 100% possible. I've already created a video called Stylus Grass in which we make the vertex normal be facing up so that the lighting data doesn't change or the way the surface is lit does not change. But by default, this is how it's going to be. It is going to face in each direction like this outside from its surface. With this data, we can say that now remember that vertex normal is in 3 directions because XYZ, right? It is basically giving the direction in XYZ because it's in 3D space basically. Texture coordinate, when we use this, it is in 2D space, right? Because it's an image. It is usually used for an image. So X and Y. And when we're using vertex normal, it is in 3D space. It can face like any direction. So if I do break float 3, we'll get 3 components. And if I connect R of this, we are going to get the R facing, which is the red facing area, as white. So if I keep moving, nothing's going to change. You could see even with this one, if I try to do this, it's going to always be white in this direction. Basically, again, like I said, in textures, you could use it in so many ways because white color is basically 1 and black color is basically 0, and anything between is like intermediate values like 0.1, 0.2 and like that. And you could use this as a mask. Same with if I use G, we are only going to get the G channel like this, and no matter how I move this, it's always going to be facing that direction. Okay, obviously then if I press B, which is the Z channel, again XYZ, RGB, UV, like these are all same. Okay, it's just a way to, you know, just a way to show float values, but what you do with this is completely your choice. Even if they show RGB, like XYZ or RGB, it's just same. Okay, now if you use this B channel, you'll see that it is only showing it on the up. So wherever it is up like this, it is showing white, and you can already guess what you could do with this. You could add some snow on top of it. You could add some different texture like moss texture, because moss will only apply on top like this, or some kind of nice blending between two materials. So if you use I guess lerp like this, I think if you press L and do left click, it shows. If you connect this as the alpha channel, you could have like two different values. So A would show on the black area and B would show on the white area like this. But now you would be like, what if I don't want to do it based on, you know, world space? I want it to actually move it based on this one like this. Then what you need to do is, this is in world space, WS, right? Add a transform node in here, and you could say that our left node is in world space. So our left node is in world space, so the source is in world space, and I want to convert this into local space. And if I do apply, this is now which one am I using? Let's use R channel so that it's easy to see. So wherever this, now you might be like, okay, so this is all R, but now if I move this, it is not actually facing R. That is because we need to go into local space, and you could see now the local space, and it is completely based on which direction it is facing. Pretty cool, right? So if you want to just show it in front of your texture, front of your mesh, then you could do it this way, and it will always face that direction. And this creates the same gradient. And again, you could do like add a float node in here, or add a add node in here to kind of offset it, right? Another method is WorldAligned. So WorldAlignedBlend, WorldAlignedBlend, connect the alpha, and by default nothing's happening because you need to give a blend bias. So let's promote this to a parameter, apply, and you could see suddenly it started working. And if I go to reverse, it will go up like this, you could see. And by default it shows the up area, so whatever is at the top. So you could also use this for what you call like snow and all, or some kind of blending. You could see with blend sharpness, you could basically make it how sharp it is, and this is, you could see how sharp it should be. And then let's say if you don't want the top area, you could see in here, if you hover, it says vector floor blend default A001. So just add a constant 3 vector. You could hold 3 and do left click, or search for constant 3, connect this, and say I want the x1, so like only x area, like 100. And now we get the x area, and again this is in world space like this. So we get some nice mass on the left side. Rest of it is same, just like addition and you know, doing offset or using power. Next is dot product. For dot product, you actually need two stuff to give you. So to explain this, I'm going to open Paint. So the way dot product works is that if two vectors are facing the same direction, it will give us 1. If they are facing perpendicular to each other like this, it will give us 0. So if they are facing opposite to each other, the value would be -1. And I think on the left side it also gives 0 like this, because it is again perpendicular like this. Okay, so when so I like to use this graph, which is 1 0 -1 0, and you could see that if two vectors are going to face same direction, it is compared to this one. Okay, so like this. So if they are like parallel to each other like this, it's going to give us 1. If this is like this is going to be like 0 0 1, right? Because it is facing completely up, and like this we get 0. Opposite we get -1 like this, and this one gives us 0 again. The thing is, if there are two vectors which are something like, I guess this and I guess this, then the value would be between this stuff. So it would be not 0 and it would be not 1, but it would be something like, I guess like 0.8, because it would be like something like this. So any vector which is like not parallel or something, it will give us, let's say it will give us between 0 and 1 value. So between 0 to 1 value. And it also gives like how much they are aligned to each other, right? And obviously we can use these values. So we know that 1 is white, 0 is black, 0.5 would be like in middle of both of this color, it would be like grayish color, and -1 we can simply think of it as black because -1 is going to be black. Anything that is below 0 is going to be black. So this way we can actually use the dot product to create a texture, or sorry, a mask. So let me connect this and let's me add the vertex normal of this one. And remember guys, when I showed you this vertex normal in here, these are like vertex normal, like tiny normals like this. If we compare all of them to straight lines, so straight line which goes like up, so this vector, so this blue line, it is 0 0 1 because it is completely up, straight up, right? All of this, like this is completely up, 0 0 1. So if we compare the vector normal to this one and do apply, you can see we get some values. So what's happening is wherever there is parallel line, so wherever there is vertex normal in here which is parallel to 0 0 1, so it is basically any vertex normal which is facing completely up, we are getting 1. But any value which is like slightly not up but slightly kind of off, we are getting like this grayish value. I don't know if we go to medium and all, it will look better. Okay, so again here you could also see that here we get some grayish value because it is not completely up. And anything that is below this one, which is anything that is lower than perpendicular, so anything that is lower than this, so any vector which is like this, like this, like this, around this much is getting lower than 0, which is completely black. Just to be safe, I like to add a saturate node. What saturate does is that anything that is above 1, it makes it to be 1, and any value that is below 0, like -1, -0.1, minus anything, basically it turns to 0. Now if I do apply, it's going to look same, or maybe some slight variation, I don't know. Okay, looks same. Similarly, if we compare the vertex normal to, let's say, x, again this is in world space, right? So it's going to be in the left side like this. We get some nice values. And again, you could add some power node in here, or add some cheap contrast, or if you want to do some offset, you could do some offset. You could add a transform node and make it be based on based on the movement, and not be like based on local axis, and not be based on like this left side. The best part is if you use vertex normal, you can actually go into your 3D software and control the vertex normal and make it face your the way you want. Obviously it changes the lighting data, but if you're using stylized look where the lighting data is usually controlled by you, or how it should look, then this is a good way to create some nice like this design or something. So yeah, that's all for this one. Multiple ways to show gradients and all. Hope this was like not much confusing, and yeah, thanks for watching. Goodbye.